where they are. I think they're here. CKS. So I was looking like some examples for today, like making images smaller, setting the user, removing, optimizing the size, right? Those are the type of things. I read the chapter this week, but I'll stop and then I'll leave it to Sebi, or if somebody has comments, you can put it in the chat. Let me
I
stop
can't
sharing.
share my screen though. I probably
Yep.
need to drop. Oh, right. Okay, I can do it now. Well done. This nice environment. Okay. So, yes, everyone, today we're going to look at the supply chain security chapter, and we have been actually in the previous chapters we were discussing about securing the Kubernetes cluster and the components, right? But now we're going to take a step back and take a look at the wider picture of the image lifecycle and how we can make it secure. And so bear in mind, at the disclaimer here, I haven't done the CKS exam before. So Carlos, if you could just sometimes maybe help me with like what type of questions might come from some chapters here, some topics
Yep.
here, that would be amazing. So we will be talking about identifying, analyzing, mitigating security risks of pre-built container images. And four concepts will be discussed here: minimizing the page image footprint, securing the supply chain, using static analysis of user workload, scanning images for known vulnerabilities. So when I started learning Docker and playing with it, I really enjoyed the concept of, Docker having layers. Docker, it has all types of different components on top of an OS, right? So, and minimized OS. So I really liked finding out what each Docker command does into the image and expecting and like investigating all those layers. So to actually, as a developer back then, I also really liked understanding what my code in the Docker file was doing into the image. So like what was the result of my application and how I should pack it in an optimum way. So it is definitely important, like very important for securing your supply chain. But also as a developer, it's so important to understand, I'm not doing development anymore, but it's important to understand how you're shipping your code, right? So here, let's see, minimizing the base image footprint chapter is actually about, you need to use pre-built images from different teams sometimes or from a company, and either manual or automatically, you should have a way to scan those image vulnerabilities. Otherwise, you wouldn't know what type of malicious code you could be deploying underneath your own application. And it should be your standard way of working to introduce new images into your workloads, right? So one scenario is about an attacker exploits container vulnerabilities. So yes, when you are building, when you want to ship your code, you need to build an image, and when you're building this, you need to find a base image. And one of the first decisions is like how you pick that image, right? So because you would need an operating system and additional components to be able to run your application on it. So a rule of thumb when picking up base images would be, so do we know the base image have the functionality we need, right? Then, do we know what other functionality this base image has in it? Because that would definitely impact the size of our image in total and the attack surface our image will have. So, and we definitely need minimal set of functionality and dependencies. So yes, picking a base image small in size is important. Why would you need a 1 gigabyte sized operating system image, right? Like it wouldn't make sense. You should be able to get those images, download those images very quickly into your clusters and get them running. So many container producers have all those variations of different types of distributions, and one of the popular ones is the Alpine. It's a small, lightweight, and less vulnerable Linux distribution. It is actually 705 megabytes. Let's see if I can use Docker here. So today I had a bit of an issue, technical issues. I was like, is it the 13th of Friday the 13th? So yeah, think about I need to download.
I think you need to put your font bigger.
Right, okay.
I think
maybe one more.
Even better.
Yeah, okay, nice. So yeah, the issue I had was I switched to Podman months ago, but Podman decided to stop working on my local. Then I switched to GKey because it's very convenient. You have the Cloud Shell editor, which is also very convenient. It just provisions this shell for you, and then you can use it as a embedded VS Code here, and you also have can get to communicate with your clusters and applications. But let's check. I seem to have some issues with my autopilot Kubernetes. So let's see. I seem to be connected. Yeah. So I have. I'm going to move faster because this chapter is really dense. Let's see how it goes until I get to the Kubernetes, admission controller part, because I will do a lot of Docker commands now. So let's switch to the Docker command. So now I'm pulling Docker Alpine image and from Docker registry, from the public registry. And let's see, I usually use this command to, figure out what has happened in this image. So yeah, this is the image ID we have, and it has all the necessary files added, and on top of it, it runs binsh, right? So the 705 megabits is all the files needed to run this image. This next layer here, it actually is a command, and it actually doesn't affect the size, but it has to be shown in the layers, right? So let me switch to the book again. So, but yeah, because this comes with a shell, this image. So that's the part where you're seeing here. And with a shell, it could be useful to investigate, your applications, your processes actually in the container, but that it becomes vulnerable because it creates an attack surface that could be exploited by bad people. So you can use a distroless image offered by Google. It will be much reduced in size, and also yeah, let's see this one. Oops. went to the Git repository. So I'm gonna check what this looks like. So if you need to investigate what is happening in a distroless image, so as you can see, yeah, it doesn't have any shell or anything in it. You could use ephemeral containers for troubleshooting next to distroless images, and so they are disposable and can be used. It doesn't, even though it doesn't allow opening a shell. So the next strategy for protecting and having small-sized images and having less attack surface in our images is having multi-stage approach. So when you're building
I
your
tell you before that what they show thing, something that can come in the exam is like asking you to given a certain image to create a Docker file out of it, or um, remove access to shell or exec, for example, at the image level, like that binary of shell or bash, or remove bash. That's one of those scenarios in Kirakoda. And then you need to like remove shell or bash of the given image, right? At least that's better than just having the image, because in production, like you don't have the luxury sometimes to use a Docker distroless, or now ChainGuard has some images that are like distroless. Like it's a distro is a specific GitHub repo, but they're commonly named like that. Like it's only images that only have the minimum, like absolutely minimum set of files, and it's basically even like for static compile programs, right? You static the library, you statically compile it into the binary, and usually the thing that you you when you start running the app, the first thing that you hit like is trying to do an HTTPS a TLS connection to something, right? An API, and it can't because it doesn't have trust certificates. So that's the absolutely minimum of getting a program to run. Either everything is in the binary, and then you need the certificates. And other than that, like usually that's what happens with like compiled binary, like C++, Rust, Go, for programs that are based on a runtime, or kind of like, yeah, I would say runtime because I was going to say Java, right? Java runtime, a Node.js interpreter, Python. So those things have a bigger footprint, and then those things drag along operating system files. So that's why usually the easiest way to get those programs to run is like, we'll get a full operating system file. But that's brings risk by having all those files around.
Exactly.
But in the exam, might be a question of like either like prevent or remove, somebody from exec, right, and sh or bash.
Yeah. Just like you said, we as developers, we shouldn't be adding the tools we need to build and pack our applications into the images. The thing we should do is to first build our image and pack it, or like put it in a directory or whatever we need, and then build it as an image that way. So for this, the technique is called multi-stage build in Docker.
Yep.
So there you can define more than one stages, and then your first stage could be building your application, and the second stage would be referring to the first stage and getting all those pre-built modules you have and putting them into your image. So for this, there's an example. So this is a flat, like one stage Docker file. So it uses this Golang base image, and then it switches into the application directory. So it obviously the Docker file would be sitting in your application code, right? So it is copying all the necessary files, first starting with gomod and gosum, and then copying all the application code, and then running tests, and then building your application, your sample application.
Yeah, so this the image, this image has the compiler, right? This is an example of Go, but it could be C++ or whatever compiler that you're using.
Yeah,
But you don't have to ship the compiler into
exactly.
Kubernetes, right, for production.
We'll
So
see
that's the
now.
aspect. Yep.
Yeah, here it is whopping like 348 megabytes of an image, which would be very tricky to download every time you need it. So so it doesn't need the Go runtime here. So how do we do it without the Go runtime? So we will be using multi-stages. So the first stage will be referred as build here, as you can see. So it is basically doing the same thing here, but putting all your application like Go program in this folder, then referring to that folder in the second stage and getting all the compiled application into this, directory, and then shipping your image like that. So
Yeah,
then
the key there is the from line in the
yes,
middle of the file. Like
exactly.
that.
So here you start with the first stage and you name it, because you should be able to refer it. As you can see, in the copy command, you have to refer to the stage, right? So you can have multiple stages, more than 2, obviously, but you have to name them with this as command.
Yeah, and by convention, the last one from is the one that your image you're producing, and you can produce different images, but that's a little bit advanced. You're going to be asked that, but you're going to be asked in the exam. We want to know if we give you like a Docker file, and this is all things related, like optimizing a Docker file to create better images, more secure
Yeah,
images by
yeah,
either, and it's
yeah,
not about optimizing the size of the file, is to optimize the files that are present that can cause security problems. By
yeah,
having a compiler or as Java SDK, right? You don't have to ship the Java SDK. You don't have to ship the Go compiler or the C++ compiler. If an intruder gets in there, and the intruder can use the compiler to compile new code, right? For example,
exactly.
he cannot access files, or maybe he can download files. But it's extra things that are there, and not necessarily that the files are bad, but if there's a CVE on a package that some of those files are like associated, then you have like a CVE alert. You have to deal with it, and that's time consuming to deal with something, to maybe spend a day finding out that, yeah, this CV doesn't affect the application, but it's like making noise in our alarm systems and monitoring things.
Exactly. So now the image size on top of Alpine with my application is only 12 megabytes, which is great. So the next thing we can do is to reduce the number of layers in the image. So
Yeah, this one it doesn't make the image more secure, right, Sevi? By
um,
collapsing the layers.
uh, it's more like about the size. I agree.
Optimization.
Yeah,
Yep.
optimization. Yeah, but you are trying to minimize the footprint of your container image, right? So that's also about that, but not necessarily
Yep.
directly like related to security. This one, I think.
Yep.
So only in Dockerfile you see some instructions, right, from run.
This is a good thing. And maybe this is feedback for Benjamin. So
Mhm.
this is not an exercise of reducing the number of layers. I think this, yeah, that's feedback for Benjamin. This section should be named how to avoid um,
getting bloated
applications not getting updated with the latest patches. So the key with this is if you run apt-get update, apt-get upgrade, apt-install -y curl, and you run that Docker build, and a week later you run that same Docker build command in the same host that the Docker engine cached the files from last week or a few days ago, and you think you're fixing curl, there's a CV in curl that you're fixing, and you do the Docker build, and you build the image and you ship it, and then you're supposed to have like scanners, right, to scan that the CV is not present. You will notice that the CV is still present, and you will go like, why? I just ran Docker build again on this file. But you're getting the same, you're not patching the dependencies of curl, and not even upgrading curl, because you're not putting what version of curl you want here. So you're hoping that you get the latest version that has the update, or if curl depends on a libgc, a library that comes with apt update or apt upgrade, you're not getting it, because what you're using is the cache file from last week when you do the Docker, so the Docker build. So this is more of bursting the cache on making sure that the software that you want to get, the latest version that has the fixes, you actually get it consistently. That's the key. That's the key element of this section. So it's not reducing the layers. It's like bursting the cache. So when you do a Docker build, you know for a fact that you're getting the upgrade. And optimally, as a best practice, when you install packages, you should put the version. So you should, if somebody comes to you and say like, what version of curl we have, like, you should not go to the image. You go to the Git repo where the Docker file is, open the Docker file and say, I have curl 1.2, 1.3.7. Okay, good. That's the version that we're shipping.
So this actually, I think, is a little bit about also understanding what these commands are doing to your Docker image, and how you can improve this. But I understand your point as well. So the commands that you would see in Docker files, only from copy run and command would actually create layers. The rest will not. So that's a great point to just remember when you're writing optimized Docker files, is that if you separate all your runs here, they will create separate layers, which would obviously maximize the footprint of your image. So what you can do is, using a logical AND operator here, if you have consequent run commands, for example, you can get them together, connect them together. So it will just run once. And create. Actually, it's not going to be run once, but it's going to create just one layer. And yes, there are great container image optimization tools, one being Docker Slim. It's going to, it will check, optimize and secure your container image by analyzing your application and its dependencies.
To see which files, trying to guess which files are not being used by are not needed by your application.
Yeah, back then, I don't remember we had this. So it was like us trying to figure out which layer happened why, and like how we can improve this, and if our application code is like actually the optimum, small size, and it was a bit pain. But
and someone posted in the chat the dive, DIVE. I put the link in the notes. Also, it's a good tool. I think it's mentioned here in Docker Slim. Is it Docker Slim?
This one's Docker Slim, but it's supposed.
Oh yeah, so it's Slim. So this is a project, and I know the co-founder of this project. So yeah, there's Slim, the open source project, and they have a company, that they have a SaaS offering, and they like offer you like to scan the things and the reports and all those things. And I think also Docker, the extension has like Docker like a command. also has like an extension that calls this code. There's a question here, dumb question, but does the soft cover version of the book includes the PDF? You have to check where you bought the book. It depends if you get it from Amazon, Kindle, O'Reilly, and so on. But usually they, software versions usually they have an EPUB and PDF.
Now, yeah,
yeah,
like something downloadable and okay, carried around. Okay. Yeah, so Dive is also another great tool for exploring the layers baked into the container image, and you can definitely identify, unused layers and if they can be improved. So let's have a look at this one as well. So
very useful. This tool is very useful to
this
kind of
is
like visualize and see the files, and then
exactly.
look for sites like what are these 20 megs coming from? What is it there? Right, and it will give you.
It's not getting slimmer, right?
But it was used a lot back in the days. Today, I think that a lot of people are starting like from images that have nothing and then start adding things into it, versus starting with images that are full operating systems like Red Hat or Ubuntu or Linux or Amazon Linux or.
One question about the exam, Carlos. So you are supposed to just work on Docker files and fix issues in the exam, right? That's cool.
Yeah.
It's directly related to
this is like getting improving security wise, improving your images, and then that's not running the images, right? Just creating good images that have are better for security. So those exercises of knocking that's why I posted the link to the Docker file best practices. Did I put it in the chat? Like you may be asked, like take this Docker file and make it a multi-stage image, or like change the default user from root to a non-root. Well, you need to know that you need to add the files, right? The user group to the Docker image, or why having multiple run commands increase the layering, but that's optimization. The other one is like making sure that when you do apt upgrade or bursting the cache, right? That's another question. And then Docker, simple things like Docker, like it's a Kubernetes exam, but I think and when I say Docker, it could be replaced with run Z or container D, or make your runtime, right? All these runtimes, and then it runs Linux containers. It's just we're used to say the word Docker. But like creating images and then creating containers and then running the container as user X or as user group X, Y, and the defaults that are inside the Docker file. So those are the things that will come in the exam.
Yeah, I didn't see that I was right there at the reference to the container security book. When you started talking about it, I just pulled the book from my book.
We covered that book. You're very good, right? I really enjoyed that book.
It's like a thin, quite easy to read book to understand, what things you can do. So I really like it.
Yeah, if people are wondering, that could be a link. Oh, added that link to the notes, the container security book. We cover that book in the book club.
Yes, that was one of.
Just a time check. We have a few minutes left. If you want to show something specific, we can jump into it.
I just will try to do as much as I can, and if you want to squeeze some next week next to the last chapter, we can do it, or we will just
signing images. There's a Docker trust. See, I've been using
Docker
Kubernetes for so long that I'm not up to date into Docker extensions. So there's a Docker extension called Trust and Sign,
Yeah, currently, yeah.
Trusted Signature, and it does like
So
that's good for the developer experience, right? Getting those shortcuts
yeah,
commands in there. So
securing your supply chain is more like automating the process of building your images, processing and producing your container images. So one important thing is signing container images, and then making sure you are actually checking that on Kubernetes as well. Um, so it actually is called image digest. It is actually derived from the contents of the container image and presented in the form of a SHA 256, and then Kubernetes then can actually compare the contents of the image with the image digest. So it will be a great step to make sure you're just using the right image. So why do we need this? Because when your image is being injected some malicious code, you have to find a way to understand, it is still the same image, right? And you have to also make sure that Kubernetes checks this and like has and use the mechanism that Kubernetes provides. So Kubelet actually does this for us, and it just verifies the image digest, and it's configured in the image pool policy. So what happens? An attacker can ingest some malicious code into container images and pushes it, and then without you realizing, you could be using that image, and then in your host machine, it starts sending sensitive information from the host machine to wherever the point is. So image checksum validation is not automatic. So you have to define in pods to make sure you add the image digest explicitly into the container image. So here you can see an example, an Alpine image with the image digest used, not image tag actually. So when you create the pod, it will check. So let's see. When you create the pod, it will check if this is the right image digest we have in the registry, and if it doesn't find that one, it actually throws an error image pull. So it doesn't pull the image, right? And so the next topic is public image registries. It's obviously for organizations that has, good security practices, should be careful using public image registries. So obviously for many purposes, for also using some very trusted base images, we're using public registries. But if you don't want, a malicious container image, if you don't want to take that risk, you can definitely have your own image registry as well as an organization. And so here, actually, as you can see, the prefix in the image name is the domain name of the image registry. So there you can check where you're getting your images from. So it's usually Docker and
and the exam, and
public.
I'm pulling the examples from the killer codes. And the exam, you may be asked of like in this Kubernetes cluster, in this namespace, there's an app that is using tags for the pods, for the specifying the image. Go ahead and instead of the tag, use digests, and that's it.
Yeah.
No more information given. So you need to find start looking using your tools, kubectl and Docker and all those things to find find the image and maybe not finding the pod, and then from the pod finding the deployment, and then from the image tag, how do you deduce what is the long string for the SHASM that you need to get, and then get that value, then edit the deployment or redeploy the deployment so that those pods start with using a digest instead of pulling by image. So that's
Yeah.
something that you may maybe get asked in the exam. So you need to be familiar with, like, why am I doing this? How do I do this?
Yeah, so there are obviously every cloud provider also has a container, an image registry, and you can also use your artifacts, use those cloud, solutions for image registries as well. There are many different options, and you can definitely set up your own private container registry. Wherever your cloud platform sits, or even on-prem. So let's move on to the whitelisting. So if you want to whitelist image registries and have,
Allow list,
well, yeah,
the new name. Yeah.
yeah, is it okay?
No, it's like just we used to be I'm doing my cognitive on my side of, like, instead of using blacklist and whitelist,
Yeah,
use allow list and non-allow list, right? Or block list.
yeah,
We don't use master nodes, we use control plane nodes, right?
yeah, and also the image branch naming has changed as well, which
Yeah,
is very
some
good.
some repos I have
Finally.
not changed. I worked with an open source project the other day, and I was using main, and it didn't work, and I spent 10 minutes to figure out
Oh,
that
really?
they haven't changed. It's sometimes
You
difficult,
have
right?
to you have to take yeah, you have to be careful actually around that. I still
Yeah.
keep seeing master.
Yeah, but
Um,
go ahead with explaining, like, how do we accept only images in our Kubernetes cluster that come only from this registry, or my registry, or my web server,
yeah.
my.
So OPA GateKeeper will take care of this for you. So you can manage the container registries that are allowed. Let me use the right wording. And so you with OPA GateKeeper, you will have a template, a constraint template for enforcing container registries. And so here it actually is just I think it must be the public OPA from the public library. Yeah.
Yeah.
So it's just a very generic constraint template. And using this, you can then define Kubernetes allowed repos. It's as a kind sitting here, as you can see. And for this example, only GCR IO is allowed. And you can also specify the API groups, the kinds that it's effective on. But actually, if I move this one, would this work? It's a match here,
If
but like
you
it
if you move
also
what?
um, the match specification here, because or if I changed it to a different kind, like if I did this.
Oh, so this kind is a thing in GateKeeper. So if you could scroll up, basically you're in GateKeeper, you kind of you're creating a CRD at the end of the day. That's why you see
Yeah,
CRD, spec CRD. So I think we cover the book of building operators. So if you want to go back and watch those videos, but basically, GateKeeper here is allowing you to create a new CRD, and this CRD will have some logic of validation to allow or not allow violations. Like that's the portion at the bottom, and then that DSL is called Rego. So basically, you're telling GateKeeper create a CRD for me on the fly, and that's the kind. So this is basically a kind that represents the policy that you want. And you saw the all the Rego code. What basically it's doing is checking if the object is pod and the image spec containers, any spec containers image, that's the string.
yeah.
And then
Well,
comparing the parameter, does it start with gcr.io or one of the things that I'm allowing?
Yeah. Well, it sits in the spec containers
Yeah. So
anyway, right?
it's going
So you
over all the
actually,
spec.containers
yeah,
of all the objects of kind pod that you give it into the other YAML file.
yeah, yeah,
And then checking that field of there should be an image somewhere there, pulling out the image field. Image, see, starts with container.image is good. If not, then start. So that's configuration. The other thing that we can add is right. That's one aspect of like not allowing a pod to have an image that doesn't comply with certain strings. So you can say, well, I don't want the image repository / image name that has the word Carlos in it because of that, right? Like I don't like it. I don't like Carlos. So that's configuration. The other thing that is done in practice is when you configure your Kubernetes cluster, you don't allow it to connect to anything, right? You close all the connectivity, all network connectivities.
yeah,
And if you want to connect to something, a container registry, and it could be in cloud like ECR, GCR, or Artifactory, you only allowed those IP addresses or those domain names only to access those things. So you're sure that people, even if they get, so for example, it could be like an attacker or misconfiguration disables the pod of remove the webhook that uh,
yeah,
GateKeeper put in there. Like that's me sneaky SRE. That's what I'm going to do, right? You have GateKeeper, and then I go around and then remove the webhook and scale down to 0 GateKeeper, and then suddenly that cluster I can put whatever image I want. But then the second layer of defense, right? It's an onion problem with security is like, well, you can not even try to connect like network wise to that other registry that lives
yeah.
in whatever other place.
I think that's a great way to just limit, secure your Kubernetes cluster as well. So whitelisting allowed image registries with the ImagePolicyWebhook admission controller plugin. So it's another way, basically, to validate the use of allowed image registries. So the way you do it is to intercept a call to the API server when a pod is about to be created. So yeah, it's
Yeah, this
enabled
might be this
the
might be
admission
in the
controller
exam,
plugin. Mm-hmm.
but in the future exams, I think this portion will be removed because this is a plugin in Kubernetes API that you can put in there that it tells it's a webhook. I could say it's a webhook configured from the API server standpoint to
Yeah.
connect to this plugin, and the plugin is for the purpose of handling images. So it's easier to configure than a generic. Like remember that some of these things were created before CRDs and webhooks were available, like from the user land. So this was one option. So the new way of doing it, we're going to have CEL based policies, validations that you
Mm-hmm.
can create a YAML, and instead of going backdoor and create this thing and run this plugin and configure the plugin, is basically with a CEL validation. You create a validation YAML file, and basically you can do the logic in there with the cell syntax to say, yeah, if it's not gcr.io or ecr.io, it doesn't end with a.acr.aws or a region, or the public docker.io, do not allow the image. And then that reduce the complexity of running like an external system in Kubernetes, like GateKeeper or Kernel. But Kernel, Open and GateKeeper are adopting that new validation policy that is in Kubernetes, but it's still in beta. So I think in a couple of releases, I think maybe the next release will be GA. But for now, you're going to take the exam. Probably you're going to be asked to configure this plugin, hands down, hands
Right.
on. Sorry.
Yeah. Let me, because while you were talking, I actually spinned up the Killer Coda CKS playground, which I was having problems with my GKE right now.
Yep.
So I installed OPA GateKeeper, and let's see how it is doing. Maybe at least I could put my hands on just one exercise today. So let me clone the repository into but it's tiny, right? Let me fix the font.
You can do Command ++ now. Ah, you have a menu. I didn't know.
I figured there was this kind of 3, lines. Yeah, that could be the menu. So yes, git clone this nice repository from our dear author Benjamin, and a chapter 6.
Not sure GateKeeper is over in the exam. I remember doing that when I took.
Oops. And this one was supply chain security. Whitelisting. So GateKeeper. We'll try this one, and maybe then we can end the session for today and decide like how.
Yeah, and for the exam, I doubt that you need to be an expert in Rigo. So I would say do not spend time like being a Rigo expert or anything. Probably if GateKeeper is around, maybe the question is around like given this policy repo, add this additional registry, right? Or change the registry allowed to this other one, and then apply the policy again.
So I'm going to apply this. Then the let's see. So this is allowing only GCR one. So I will then try Docker, and let's see if we will be able to run a pod. Okay.
So that's allowed.
Oh yeah, GCR is allowed. So the rest.
Well, that created what, a pod or a deployment? Because that's the trick. When you have a validation like this, and you created a deployment, the deployment doesn't create the pods yet, so you will not see the error in your kubectl, right? The one that's going to get the error is the deployment controller.
Yeah, let me just try to run this command first to see if it's,
So that one, yeah. So kubectl run actually sends a pod, so you will get the error back.
But let's check if
yeah, the next one has the registry.
This is run as well, but this is the allowed registry. Let's try the allowed registry just to check. Yep. So I'm going to check. I think there was one example here. No, let's try to create one.
This is why things like GateKeeper and Kyverno are easier to use, because you just create YAML files at the user level, and it's easy to create policies like that versus running the image plugin thing.
Yeah. Yes, I have. So I have this sample here. Let me just paste it. So this was. So I'm gonna just use the Docker Alpine.
And it would not allow it, right?
Yeah. So I can use Docker pull Alpine, but I would prefer a tag, to be honest. That's terrible practice. Just use tags. Okay. So let's try this one. I don't want commands, actually. Oops, I don't want the Docker pull, but I want the...
Well, the image is just Alpine, and then any of those tags.
Yeah, image is just Alpine. I just want to use the Docker registry.
Just docker.io.
Yeah, Docker.io, right?
But the thing is, just for folks that are familiar, if you don't put a server name, a host name,
It's
then it will use the default one configured by your container runtime. And this could be Container D or like Cryo or Docker Engine.
try this.
And for the most part, because all the environments and vendors want to be consistent, Docker.io is kind of like the default for most environments. Some environments, like they have a different default, like could be your Artifactory or your ECR or your ZCR.
So as you can see, I got this error message on the creation of this pod as well. But you wanted to try.
Oh, here's the trick. So if you update the policy
Mhm.
to also allow GCR.io and also allow
Yeah,
Docker.io, it will still not work because in your pod YAML file container, you didn't put the host name docker.io in front of it, even
right.
though the default is docker.io. But as you can see, this validation happens at config time, not when kubelet or when kubelet is downloading the image.
Mm-hmm. Okay. Yeah, that's a great point. Do you want me to try it as well?
No, I think that's
Okay.
fine. I think we
Okay, maybe
we
it's
proved the
time
point.
we're 10 minutes over, and maybe we can close this session and decide, how we wrap up the existing chapters existing parts from this chapter. But thanks for joining us today. And I haven't been able to touch too much on the kubectl part, but now I finally in the end managed to get something working.
No, I think
Beautifully. I do
the
like the environment as well, by the way.
yeah, it's easy, right? So and it
Yeah.
has good exercises to get used to.
Thanks for
Also,
letting.
the downloading. This is also a good idea. Get there's a CKS killer coda environment only, and then what you can do is like exactly what Sevi did: download Benjamin's from the book repo, and then practice the chapter
Yes.
exams from the repo. I think I will do that also.
Yeah,
Plus
and
the
yeah,
ones available here.
because it said right when it was spinning up, it said that it will have this CKS specifications in this cluster we're just spinning up.
Yep,
So
yep. The same tools that you will have Vim configure. So if you
exactly.
click on desktop, that's what I've been using, but I think it would not work for you. But that's the one that I'm using at the top.
Yeah, this has 1 hour time limit. So
But exam desktop doesn't work, or does it work? Or no, I don't know. If you click exam
plug
desktop at the
can you
top,
this
on
this this one's in browser mode. What do you mean?
no, if you click the word that says exam desktop on the top left,
Top
where it says
left
editor tab 1, to the right,
to the right.
where at the top of the terminal, when you have the tabs on the left.
I just have new terminal here, but
That's okay. It's in the center of your screen. It says exam desktop editor
yeah.
and tab 1. Yes.
Sorry, guys. Oh, okay, nice.
So editor is VS Code, but I don't think you will have VS Code. I don't know if chat is still around in CKS. But
They
click exam desktop. Does it do anything at
they
the top?
forgot some folders in it, like music, pictures. This is the repo I got now.
Yeah. Yep.
Yeah. Yeah, I will keep playing with this, and maybe next time I'm presenting, I will use this Killer Coda playground as well. I think it was really convenient.
Yep.
Back then, I was using Kubernetes Playground and Docker Playground for lab purposes, for teaching purposes, if I didn't have to do it like over for an hour. But yeah, thanks for letting me know. That's great.
Yep. But yeah, so for folks that are still here, yeah, this is we covered this a little bit of the chapter, and then next week, my comment will cover Falco and runtime, and then that's it. And then we'll see if we want to do another right away, do a book, or maybe I do a couple of sessions on going over the killer coda exercises.
Yeah, maybe then I can finish the rest of the exercises in the chapter as well.
Oh yeah, yeah.
I can join you and definitely run one session.
Yeah. We can divide a few of them.
Okay. Okay, thanks guys for joining and for being here and being as awesome as always. Hope to see you around again. And cheers.
Yeah. Thank you so much for attending. See you next week.
Bye.
Bye.